So guys, this is the LED over here and this is the button. Let me press the button. See, the LED turns on. If I leave the button, LED turns off. If I press the button, LED turns on and remains on. See, if I press the button, only then the LED turns on. So let me show you the schematic. So guys, this is our circuit. We just connected the push button with a PIC. The signal is at pin number B5 and push button is connected in such a way that whenever it is pressed, a 1 is sent. And then we have an LED connected at the pin number D1. So let me show you the code. So in the code over here, you can see that we just initialized our button pin. We initialized the LED pin. Then we went to our forever loop. We checked if the button is pressed. We gave some debouncing delay. If the button is still pressed after 50 milliseconds, we just turn on the LED. And else the LED is off. Simple code and giving us this simple results. See, it is working. Guys, welcome to learning microcontrollers. In this video, I will show you how to connect and program a push button with PIC16F877A microcontroller. This will be a step-by-step guide. So let's get started. So guys, this over here is our PIC16F877A DIP 40-pin microcontroller. It's easily available in the market, and this is the DIP vision. It is also available in the SMD package as well. So let's get started. So guys, there is our push button. It's a tactile push button having 2 pins. There is a 10K resistor. We need a 10K resistor to interface a push button with the PIC microcontroller. This 10K resistor decides either your push button, whenever it is pressed, either a 1 will be sent or a 0 will be sent. Now I will show you how to connect this push button with a microcontroller using this 10K resistor in such a way that whenever the push button is pressed, a 1 will be sent. So let's see how to do this. First of all, you must know there are 2 pins. I name the 1 pin as signal S, the other pin as positive. So you can shuffle these 2 pins as well. You can rename them with whatever name you prefer. Like this push button is basically a non-polar component, so shuffling the pin will have no impact on its functionality. So the left one is the signal pin, the right one is the positive pin. That's what I named them. Now let's do the connection. For the positive pin, just connect it directly with the VCC pin of your PIC16F877A microcontroller like this. Now for the signal pin, connect it to the one end of that 10K resistor like this. And from the same pin, you will take your output. For that, you may use any available GPIO pin of your PIC16F877A microcontroller. I'm going to use the pin number B5 like this. Now from the other end of this 10K resistor, you will send this pin to the ground of your PIC like this. In this way, this push button is connected. Now this push button is connected in such a way that whenever it will be pressed, only a 1 will be sent to your microcontroller. And an easy way to identify either the push button is gonna send 1 or 0 is that check in your circuit if this resistor, 10K resistor, one end is at the grounding end. This means that whenever the button is pressed, a 1 will be sent. In other case, it will be a 0. Now guys, for you to understand either a 1 is sent or not, we will program our PIC in such a way that whenever a button is pressed, an LED will turn on. Now we bring in an LED, this LED. So to verify that our button is pressed, this LED must turn on. Now let's connect this LED first. You can see this LED. It is a crystal type 5mm LED, easily available in the market. It has 2 pins. The left one is the power, the right one is the ground. Now to connect this with the PIC, again you are going to need a resistor. This time it's a safety resistor. It makes sure that your LED do not get a very high current and get burned. So it can be of any value from 100 ohm to whatever value you prefer. The higher the value of this resistor, the dimmer your LED will glow. So select it accordingly. I have this 220 ohm. It's a very, you can say, ideal resistor for a LED working at 5 volt. Now let's do the connection. For the ground pin, just connect it to the common ground of your PIC16F877A like this. For the power pin, connect it to the one end of your 220 ohm resistor. From the other end, you may connect it to any available GPIO pin. So I'm going to use this pin number D1 like this. In this way, my connections are completed. So this is our simple circuit. So whenever this button is pressed, this LED must turn on. That's how we are going to program this PIC. So guys, let me introduce you to the hardware, then we move on to the programming. So guys, this is the circuit I have over here. You can see that this is the only board I'm going to use. Rest is just a trainer board. Now this is the LED, this one. You can see that it is connected to pin number D1 over here, and this is the push button connected to pin number B5 over there. You can see that this is as shown in the presentation. So circuit is just for the demonstration purpose. So let's get to our MikroC. So let me open the magnifier so you guys can see better. Okay, there you go. So this is the MikroC for PIC. I also have a lecture on this, how to download and install this for free. You can follow that. If you don't have the software, click on File, New Project. This window pops up, New Project Visit. Click on Next, write the name of the project, push button, tutorial. That is the name I wrote. PIC16F877 is the microcontroller, and the crystal I have connected to the pin number 13 and 14 of my PIC16F877A is 16 megahertz. Click on Next and finish. Now guys, this window pops up. Before you do anything else, first of all go to File, click on Save to save your work. Here you go, click on Save. Now guys, first of all we need to initialize the pins. We have two pins, one is connected to the LED and one connected to the push button. Now first of all we initialize the push button pin, trace B.F5 equals to 1. Now trace is the direction register in this MikroC for PIC, and B is the port name, F5 is the pin number, and 1 means the pin has been declared as input. If it's 0, it means it has been declared as output, and a button is always connected to a input GPIO pin. So initially I want the button state to be B.F5 equals to 0. Like initially I want my button pin to be at 0 state. Why? Because if the button is pressed, a 1 is sent, so by default it must be 0. We give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now this is our button. Button is initialized. Let's initialize the LED pin. Trace D.F1 equals to 0. Now see the difference. For the button we needed the GPIO pin to act as an input pin. For the LED we need the GPIO pin to act as an output pin. Now trace is the direction register, D is the port, F1 is the pin number, 0 means the pin has been declared as an output pin, and this is for the LED. Now initially D.F1 equals to 0. I want the LED to be off. If I give it 1, it means the LED is on, 0 means the LED is off. Again we give the initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now our LED is initialized and our button is initialized. We can go for the forever loop. So we start writing the forever loop from here. While 1, forever loop starts here, ends here. Inside it we write if port B.F5 double equal to 1. Like as I told you earlier, our button is connected in such a way that whenever it is pressed, a 1 will be sent. So we check if port B.F5 double equals to 1, then what should happen? Wait for 50 milliseconds if the button is pressed. Again check. If the button is still pressed, then consider it pressed. Close both the loops. Now why I use this delay? This is the debouncing delay. The problem with these tactile push buttons is that they are very low quality buttons. If you do not add this delay, then there is a possibility that the button may get shorted due to any phenomena like static shock, electrostatic shock, or some air particle or something in the air, or EM reaction, or whatever it is. So your button will get pressed and your LED or whatever it is in this loop will get initiated, and that will be a terrible disaster in case it's a big machine. So we use this delay called debouncing delay to make sure that this never happens. So if our button is pressed and it is still pressed for like 50 milliseconds, only then consider it to be pressed. So in this way, if there is an electrostatic phenomena or static shock or an air particle, it cannot be there for like more than 50 milliseconds. It will be like maximum of 8 milliseconds, 4 milliseconds, 3 milliseconds. But this is a huge delay. So this is our safety delay. Now, if the button is pressed and if it is still pressed after 50 milliseconds, then consider it pressed and turn on the LED. LED is at port D.F1 equals to 1. So the LED gets on. Now else, else in other case, if the button is not pressed, then again go back to the initial state. Initially our LED was at 0. So now the code is very simple. We just initialize the button pin, we initialize the LED pin, then we went to our forever loop. We checked if the button is pressed and we waited if the button is still pressed for 50 milliseconds. After that we again checked if the button is still pressed, then we turned on the LED. Now else if the button is not pressed, the LED will remain off. So simple code. So we build it, check for errors. Okay, built, no error. I do that again, still no error. Okay, that's perfect. Okay, now we go to our PIC16 programmer tool to run the code. So this is my PIC16 programmer tool. If you don't have this tool, you can go through my video lecture in which I have shown you how to download and install and use this tool. It is very simple and easy to download and install and use. Please, you must have this. Click on file, click on import. So this is a hex file we just created. Double click, click on write. Okay, erasing device, it is writing the new code. You have to wait. Let me show you the hardware in the parallel. So wait for the code to be written. Wait. Okay, once it's done, I'll let you know. Okay, here we go. So it's done and the circuit is powered up using this on key or on button on the PIC3. This means that our PIC3 is powering up the circuit. Okay, let's check. So guys, this is the button over here and this is the LED, and this is great. The LED is off by default because as per our initial state, the LED must be off because LED is set to 0. Now I press this button, so LED turns on. That's great. If I keep it pressed, the LED remains on. So that is what we just wanted. You can see that it is working. See, the code is working, the button is working. Now this is a tutorial of how to interface this button. If you have any other application, like you want to drive a motor or you want to run some certain piece of code or whatever it is, that will come inside this loop over here. Inside this loop, you will write your code, and whatever you want the opposite, you write over here. So this is a technique to interface the button. It can be the limit switch, it can be the proximity sensor, it can be a relay, whatever it is, you just have to use the same technique. So basically the tutorial is about using a technique to interface an input device over the GPIO pins. So you can see that it is working like a charm. So guys, this is it for this lecture. If you guys have any questions, please do ask. So we'll see you in the next lecture. So goodbye until then.